Welcome back. Today we're going to be working on 7.7 notes, factoring differences of two perfect squares. Before we go ahead and get started though, let's go ahead and talk about what it means to be a perfect square. Okay. What it means to be a perfect square is when I take the square root of a number, I'm going to get an integer back. So let's talk about all the numbers that I can do that way. So 2 squared, that would be 4. 3 squared is 9. 4 squared is 16. Again, my perfect squares would be 4, 9, 16. More perfect squares, 5 squared is 25. 6 squared, 36. 7 squared, 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. And lastly, 13 squared is 169. Again, 25, 36, 49, 66, 81, 100, 121, 144, 169. Those are all my perfect squares from 1 through 13. So let's talk about what we've already seen. Simplify. Remember, simplify means multiply or combine like terms. For example, 1, we're going to distribute. So I go x to x makes x squared. X times negative 5 is negative 5x. 5 times x is positive 5x. 5 times negative 5 is negative 25. When we combine like terms, you recognize that negative 5x plus 5x is 0, so it goes away, which drops down to x squared minus 25. Now let's shoot over to example 3. Do you recognize that? Actually, you know what? Let's continue with example 2. So in example 1, you recognize that the middle terms go away and you're left with x squared minus 25. Also, you should recognize is 25 is on that perfect squares list. That's 5 squared. All right, let's go ahead and do example 2. Again, I'm going to distribute x times x, which is x squared. X times negative 7, negative 7x. 7 times x, positive 7x. And then 7 times negative 7 is negative 49. Again, when I combine my middle terms, they both cancel out because negative 7x plus 7x is 0. So what only drops down is x squared minus 49. Again, we should recognize that 49 is also on the perfect squares list. It's 7 squared. Okay. Also, if you recognize my two binomials, they're the same binomial except one has a plus and one has a minus. X plus 5 and x minus 5. Same goes with example 2, plus 7 and minus 7. So, when the numbers are the same but with opposite signs, number 1 is 7, 1 has a negative 7, the middle term cancels out. Cancels. All right, so that's what we should know. Now let's talk about what we are going to learn. What we're going to learn how to do today is factor x squared minus 49 into the two binomials. But we're normally used to seeing the 3 terms. Remember what multiplies the third that adds to the middle? But recognize that there isn't a middle term. But what you should recognize is 49 is a perfect square. So we're going to start by splitting x and x. Now, since 49 is a perfect square, we're going to just factor it into 7 and negative 7. Remember, because there is no middle term, so it has to add to 0. 7 negative 7 adds 0. And I factor the plus 7, x minus 7, which you recognize from example number 2. Right? Another way we can see it is, let's look at example 4. Again, you have a binomial, but you should recognize that 4 is a perfect square and 9 is a perfect square. So instead of breaking up 4x squared into 4x and x, I'm going to break it up and basically take the square root of it. So I'm going to break up this 2x into 2x. And I'm going to break up 9 as 3 and negative 3. Again, because my middle term is 0, my factors of my third term have to equal 0. So my factors are 2x plus 3, 2x minus 3. Again, you can check that by redistributing and checking to see if you got what you originally had. Summary. When the terms are perfect squares, we form two binomials, one with a plus, one with a minus. So remember, it's going to be a plus b, a minus b. So they're same binomials, except the only thing that changes is the plus with one and the minus with the other. All right, let's go ahead and factor. Let's do number one. Again, you should recognize that 81 is a perfect square. So we're going to break up x squared, x, and x. If you recognize 9 squared is 81, so we're going to break it up as 9 and negative 9. So my two factors are x plus 9, x minus 9. Okay, let's go ahead and do example 2. Again, you should recognize that 144 is a perfect square because round squared is 144. So I'm going to break up x squared, again, as x and x. 144 is 12, and the other one is negative 12. Again, because there is no middle term, it's canceled out. So whatever I'm choosing in my combination has to equal 0. But there's only one combination since it's a perfect square. So it's x plus 12, x minus 12. All right, let's move on to example number 3. Again, 1 might not be on your list for perfect squares, but 1 is actually the first perfect square because 1 squared is 1. Again, I'm going to break up x squared as x and x, 1 as 1 and negative 1. My factors are x plus 1, x minus 1. Oops, okay. All right, let's move on to the back. I'm going to go ahead and have you pause your video to complete number 4 and 5. When you're ready, go ahead and press play and check to see if your answers are correct. All right, let's check to see if you got the correct answer. So 36 is a perfect square. I'm going to break it up as 6 and negative 6, since 6 squared is 36. So my factors are x plus 6, x minus 6. And for 5, again, 64 is a perfect square. It's 8 times 8 is 64. So I'm going to break it up as x plus 8, x minus 8. All right, let's go ahead and do 6. X squared is x and x, and then on the front, remember 2 squared is 4. So since it's 2 squared, I'm going to break it up as 2 and negative 2. But I'm going to get this 2 and negative 2 because I need to make factors of negative 4. The only way to get to a negative number is a positive times a negative. It's going to be x plus 2, x minus 2. All right, let's continue. Let's go ahead and pause your video. Complete 7 and 8. When you're ready, go ahead and press play to check to see if your answer is correct. All right, let's check to see if you got the correct answer. 7 is going to be x plus 11, x minus 11. I chose 11 because 11 squared is 1, and that's what I want. 8 ends up being x plus 10 and x minus 10. Again, I know to use 10 because 10 squared is equal to 100, and that's what I want. All right, let's go ahead and do 9 together. I'm going to break up x squared as x and x. How am I going to break up 9? Well, I know 3 squared is 9. So I'm going to break up this 3 and negative 3. So x plus 3, x plus 3. All right, let's get a little bit tougher and move on to 10. You recognize Now I don't just have x squared, I have 36x squared. Recognize that 36 is a perfect square as well, because 6 squared is 36. So I'm actually going to break up 36x squared, 6x, and 6x. You should also recognize that 1 is a perfect square because 1 squared is 1. I'm going to break up 1 as 1 and negative 1. I'm not going to have 6x and negative 6x here because I have to make a positive 36. Okay, so the only way to make a positive is 2 positives or 2 negatives, but I don't need the 2 negatives. So my factors are going to be 6x plus 1 and 6x minus 1. All right, on to number 11. Again, you should recognize that 9 is 3 squared is 9, and 64 is equal to 8 squared. 8 squared is 64. So I'm going to break up 9 squared with 3 to be 3x and 3x. And I'm going to break up 64 with 8. Again, since it's negative, 64 is going to be 8 and negative 8. So my factors are 3x plus 8 and 3x minus 8. All right, please go ahead and pause the video and complete number 12. When you're ready to check your answer, press play. The correct answer for number 12 is 5x plus 4 and 5x minus 4. I knew to use 5 because 5 squared is 25. I knew to use 4 because 4 squared is 16. All right, now let's do a mixed review and put all of this together. Now, no matter if you are factoring by just a GCF or a trinomial, what we did in the last two videos, or a perfect square, you always have to start with the first step. Okay? Always have to factor the GCF no matter what type of factoring problem it is. So always your first step is check for a GCF. Then step 2, check to see, after you factor the GCF, check to see if it's a difference of two perfect squares. So if we're using, 1, 4, 9, 16, those numbers, it's generally going to be a perfect square. And then if it's a trinomial, remember, use the guess and check method. Remember the inners and outers, guess and check method. All right, so let's go ahead and do a mixed review. Again, no matter what type of problem it is, check for a GCF. So if we notice with 1, I do have a GCF because 3 can go into both terms. So when I factor out a 3, I'm left with x squared minus 9. Remember, anytime we factor a GCF, we should always check to see if we can factor our leftovers. Okay? Well, if you recognize 9 is a perfect square because 3 squared is 9. So I can factor this even further. Again, I'm going to split it up with x and x. And 9, I'm going to split up with 3 and negative 3. Be very careful to drop down that 3. Once you pull out a GCF, you should always keep dropping it down. And my factors are going to be x plus 3 and x minus 3. All right, let's move on to example 2. Again, always check to see if you can factor the GCF. You should recognize that each term is divisible by one number, and that number is 3. We're going to divide everything by 3. Again, and I'm going to put the GCF on the front, and I'm left with x squared minus 13x plus 30. Again, you should always check to see if you can factor further and the left with a trinomial. So let's go ahead and do the guess check method. So go up with x and x. And since it's an x and x, I can easily find out the combination right away. I don't have to check the inners and outers to determine the correct combination. So we're looking at factors of 30, so things that multiply to 30. So let's list them right here. So we're going to run out of room. We have 1 and 30, 2 and 15, 3 and 10, 5 and 6. And I'm looking for the combination that adds to negative 13. So if you recognize 3 and 10 add to positive 13. That's an easy fix. They both become negative. They both become negative because it's a positive 30. So my two numbers that are going to work is negative 3 and negative 10. Again, don't forget to drop down that. Once you factor it out, it just keeps dropping down. And my factors are going to be x minus 3 and x minus 10. All right, let's move on to example number 3. Again, no matter what, you always check for a GCF first. You should recognize that in number 3, both are divisible, all three of them are divisible by 2, but since they all have an x, remember you always choose the smaller exponent between 3, 2, and 1, it's an x. So I'm going to pull out that 2x down front, and I'm left with x squared, because 2x cubed divided by 2x, the 2's cancel, and I subtract the exponents. Plus 4 divided by 2 is 2, x squared divided by x, remember numerator wins by 1. And then negative 48x divided by 2 is negative 24, the x is canceled. Again, I'm left with a trinomial. Always check to see if you could factor further. So I'm going to break up x and x, and now I'm going to list all the factors of 24. Since I broke this up as x and x, it's going to be pretty easy to tell which combination it is. I don't have to check my inners and outers. So let's list everything that makes it negative 24. Remember, each combination is going to have only one negative. Negative 1 and 24, negative 2, oops, my pen stopped working, and 12, negative 3 and 8, negative 4 and 6. We are looking for combinations that add to 2. So you should recognize it. I have negative 4 plus 6, that equals 2. The first step, again, is to bring down that GCF, so bring down that 2x. And my combination is going to be x minus 4 and x plus 6. Since negative 4 and positive 6 is my combination. Now, the order does not matter, so I could have had x plus 6 first instead of x minus 4. What does matter is the sign. So the negative must be with the 4 and the positive must be with the 6. All right, and lastly, let's continue on to example 4. Again, you should always check for a GCF, but there's not a number that goes into both 25 and 81. But you should recognize that 25 and 81 are perfect squares. 25 is a perfect square because 5 squared is 25. 81 is a perfect square because 9 squared is 81. So this is just a difference of two perfect squares. So I'm going to break up 25m squared is 5m and 5n. Again, one of them is not going to be negative, so they're both positive because it's a positive 25. And 81 gets broken up to 9 and negative 9. Again, one of them is negative because of that negative sign right there. So the factors are going to be 5m plus 9 and 5m minus 9. All right, go ahead and pause the video or stop the video, and complete your homework.